You know, pretty much every single day, millions of us get in our cars, we put them in drive, and that's it. We just go. We never really think about it, but inside that transmission is one of the most incredible, complex, and just elegant pieces of engineering you'll ever interact with. So today, we're going to pull back the curtain and look at the magic happening inside that metal box. It's one of those things we take for granted, right? We all know what it does, obviously, but the real mystery is how. How in the world does your car just seamlessly shift gears without you ever touching a clutch pedal? And how does it know when to shift? Well, the answer is this brilliant mix of physics and, honestly, some very clever logic. I mean, if you could just crack open that transmission case, you wouldn't find just a few gears. You'd find this whole world, a maze of planetary gear sets, tiny little fluid pathways, clutch packs, valves, sensors. It's like this incredible mechanical symphony, and every single part has a job to do to get power to the wheels smoothly and effortlessly. So to really get this, we have to start with the basic problem all transmissions have to solve. Your engine, it has a sweet spot, a pretty narrow range where it makes the most power. But your wheels, they need to spin at all kinds of different speeds. Now, a manual transmission solves this by making you, the driver, physically choose different pairs of gears. An automatic, though, it uses a completely different, and you could say, a much more elegant solution, the planetary gear set. And this right here, this is the secret sauce. This is the absolute heart of how a modern automatic transmission works. It's not about sliding gears around. It's all about this one incredible invention. So, why is it called a planetary gear set? Well, it's pretty obvious when you look at it. Right in the middle, you've got the sun gear. Orbiting around it are a few smaller planet gears, and they're all held together by a carrier. Then surrounding that whole assembly, you have the ring gear, with teeth on the inside. Now here's the magic part. All three of these components, the sun, the planets, and the ring, can all spin on their own or be held perfectly still. And that is the big reveal. That's the million-dollar idea. You don't need to slam different gears into place. In fact, all the gears are always engaged with each other. To get a totally different gear ratio, all the transmission has to do is stop one of those three components from spinning. That's it. It's that simple and that brilliant. Okay, so check this out. Let's say you hold that outer ring gear still, and you spin the sun gear in the middle. The planet gears are forced to kind of walk around the inside of that ring gear, and boom, you get a big gear reduction, perfect for first gear. But now, what if you hold the sun gear still and power the ring gear instead? You get a completely different gear ratio. And then for the final trick, what if you just lock all three components together so they spin as one single unit? Well, now you've got a one-to-one direct drive for highway cruising. It's just genius, isn't it?
All right, so we get the what. We know the planetary gear set is the key, but that brings up a huge question. How does the car decide which part to hold still and when? This is where the control system comes in. You've got the brains and you've got the brawn.
Let's start with the brawn, the muscle of the operation. The actual physical work of grabbing and releasing parts of that gear set is done by things called multiplate clutches and brake bands. You can just think of them as super strong, super fast clamps. When the transmission's brain says shift, it sends a blast of high-pressure fluid to a piston, which then clamps down on one of these clutches and instantly locks a part of the gear set in place. But before we get to the brains, we absolutely have to talk about the torque converter. This is the automatic's answer to the clutch pedal. It's basically this fluid-filled donut that sits right between the engine and the transmission. It's what lets your engine keep running when you're stopped at a red light. But here's the really cool part. When you hit the gas, it uses the physics of that fluid to actually multiply the engine's torque, giving you that powerful launch from a stop. Now the brains of the first automatics were just mechanical marvels. Seriously, no electronics, not a single wire. They worked by perfectly balancing two different fluid pressures. One pressure came from a governor, and it got stronger the faster the car went. The other pressure was tied to your gas pedal. The harder you pressed, the stronger it got. When the speed pressure was finally strong enough to push against the throttle pressure, a little valve would literally slide over, change where the fluid was going, and trigger a gear shift. Okay, so let's fast forward to today. We've replaced that amazing mechanical balancing act with an even more powerful electronic brain, the Transmission Control Module, or TCM. This little computer is watching everything: your speed, how hard you're on the gas, the engine load, the temperature, you name it. It takes all that data and uses it to control tiny electronic solenoids. These solenoids manage the hydraulic pressure with incredible precision, giving us shifts that are way faster, way smoother, and a whole lot more efficient. And here's something you might not know.
None of this, not the brains, not the brawn, could work without this unsung hero, the automatic transmission fluid. You might think ATF is just oil, but it's so much more than that. It's the hydraulic fluid that actually makes the clutches work. It's the coolant that carries away all the intense heat. It's a lubricant, of course. And it even has special friction modifiers to make sure those clutches grab on just right. Not too harsh, not too soft. It's a seriously high-tech liquid.
Okay, so we've got all the pieces on the board. We've seen the gear sets, the clutches, the torque converter, and the brains. Now let's put it all together and see how this mechanical ballet plays out on a normal drive.
Picture this, you sitting at a red light. The engine's idling, but that torque converter is slipping on purpose, so you're not moving. The light turns green, you hit the gas. Instantly, the torque converter does its thing, multiplies the torque, and you get that nice surge forward. As your speed climbs, the TCM is watching. It says, okay, time to shift. In a fraction of a second, it tells the solenoids to release the clutch for first gear and apply the clutch for second. It's this perfect handoff, and this little dance just repeats all the way up to highway speed. Then, once you're cruising, another clutch inside the torque converter locks up, creating a direct connection to save fuel.
So just think about that. That perfectly smooth shift that you barely even noticed, that wasn't just one thing happening. That was a complex, computer-controlled hydraulic ballet, all timed down to the millisecond. A perfect, invisible handoff from one gear to the next. It's incredible.
So, after all that, when you really boil it all down, what is an automatic transmission really? At its core, it's really a system for turning engine power into motion that's actually useful at any speed. And it does that by combining four key things: that ingenious planetary gear system to create the ratios, a hydraulic network to be the muscle, a torque converter to manage the power, and an electronic brain to conduct the whole orchestra.
So the next time you get in your car and just slip that lever into drive, maybe take just a second to appreciate what's happening under your feet. You're not just moving a lever, you're setting in motion a system that replaced your foot on a clutch with fluid dynamics and replaced grinding gears with the silent, precise logic of hydraulics and electronics. It really is effortless motion, powered by decades of absolutely brilliant engineering.